Okay, so welcome back. This will definitely be the last video in Chapter 8. It'll be a very short video. I was hoping I could have squeezed this information in the previous one, but I just didn't have quite enough time. So there's really just one last concept to talk about in this chapter, and that is the fact that angular velocity and angular acceleration and angular momentum are all vector quantities. And we know from talking about linear velocity and acceleration and momentum that vectors have a quantity, a magnitude, and a direction. So if you have something that is spinning like this, and if we were to look at some point on its surface here, that direction is constantly changing. So how can we describe the direction of a vector quantity that appears to be constantly changing? And the answer is that the rotation, the spinning, the plane that occurs on, like this flat disk, is perpendicular to the direction of the vector. So like here, we would say that although the disk is spinning round and round and round horizontally here, the direction associated with the angular velocity is straight up. And it's also important to keep in mind the right-hand rule. Now, normally in a classroom setting, I would be showing this with my own hand in front of the class, so it's kind of difficult to show here, but I'll try to just use this illustration of a hand. And basically the idea is if you look at your fingers and the way they're kind of wrapping around this the rod in this case that it's holding on to, the fingers are pointing in the direction of the rotation. Okay, so like going from your palm to your fingertips, that's the direction. And if you're using your right hand, then your thumb points in the direction of the vector. So you wouldn't want to use your left hand because it would be pointing in the opposite direction. So in other words, for this type of rotation, as we look down on it from above, it appears to be going in a counterclockwise direction, which means the vector is going straight up, not straight down. This would be the opposite direction of the vector. So it's important to remember that this is the right hand rule. This doesn't work with your left hand. It's the right hand rule. Follow the kind of direction of the way your fingers curl into your palm, and that's the direction of the rotation. And then the way your thumb points is the positive direction of the vector. And this may be I know this shows up in other classes, other engineering classes, the right-hand rule. It's basically a good way to remember the orientation of X, Y, and Z axes. So you'd have your X, like with your finger pointed straight out, your index finger, and then your other fingers wrap around into your palm. They're kind of, oh gosh, this is bad drawing, but they're curling around in this direction, so that's the Y, and then your thumb points up in the Z direction. So that's the way the positive X, Y, and Z axes are related, can be found by the right-hand rule. Like point your finger almost like a pretend gun in the X direction, your other fingers point in the Y, and your thumb points straight up in the Z direction. So let's go on to another image here that might help describe this a little bit better. So if we look at the person here, the person, this is kind of like a giant disc-shaped treadmill. The person is going around in this direction. Okay, so when we look down on him from above, he appears to be going counterclockwise. So if we use our right-hand rule to determine what is the direction of his angular momentum, our thumb is going to point up. Okay, so the direction is going that way, so his momentum is up. Now, if we were to look at the disk and how it's moving, it's rotating the other way. The disk is moving in this direction. Okay, so if we curled our fingers in that direction, let me erase my poor attempt at drawing a hand here. If we wanted to curl our fingers around in that direction, they would be going the other way. And therefore our thumb would be going down. And so the momentum of the disk is pointed down according to our right-hand rule. So the momentum of the man is up, the momentum of the spinning disk is down. Hopefully I didn't make too much of a mess of that explanation. But that is the last concept I wanted to explain. So that's it for Chapter 8. As always, if you've got any questions, post them in the discussion board, and I'll see you next week with Chapter 9.